Pleasant good day to all present. Esther Lambert here, Research Associate with the Institute for Catastrophic Loss Reduction. Just extending a warm welcome to all present to ICLR's monthly Friday forum. The topic today, Edmonton's approach to urban flood management. Just as we give a few of the attendees a chance to sign in, I'd just like to take a moment to draw your attention to a few housekeeping details. Please save your questions till the end of the presentation. We do have a half-hour period at the end where we will take questions. You can post your questions. If they come to you during the presentation, post them in the Q&A chat box at the bottom of your screen. If you have questions relating to technical issues, also post them in the general chat box. And so also slides and recordings for the presentation will be available on the ICLR website, iclr.org, under workshops. It'll also be available on the ICLR YouTube page, ICLR Info. Just a quick note that the next Friday forum will be on August 20th. So please mark your calendars, and we'll have two speakers then, looking at the National Guide for Wildland Urban Interface Fires that was just released. So please mark your calendars for that. So our topic for today, urban flood management. And that's really a topic that all of us is interested in, and it's highly important. We're interested in it. We have small businesses have an interest, insurers, municipalities, and homeowners. And when we think about climate change and its projected impacts, we know that flooding is one of the major things to consider. And we know that flood mitigation and adaptation is something that a lot of municipalities are placing at the top of their agenda. And so today we're really, really happy to have a special guest talk to us about what Edmonton has been doing to reduce its risk of flooding. And today, so we want to welcome today Susan Ancel, who is the Director of Water Planning for EPCOR Water Services in Edmonton, Alberta. Her previous roles include Director of Stormwater Strategies, developing an integrated resource plan for flood mitigation, and Director of Water Distribution and Transmission for EPCOR. And by way of training, she is a mechanical engineer with over 30 years experience in the municipal utility sector. Susan has served on numerous industry committees, the most recent being the Board of Directors for the Canadian Water Network. And so we really want to welcome you today, Susan, and just pass it over to you to begin your presentation. Thank you.
Thank you very much, Esther. So I will get started right away. So we've got about an hour of slides. And so I'm going to spend some time going through how we developed our stormwater integrated resource plan and what were some of the challenges that we had to overcome and what were some of the decisions there, as opposed to really focusing on we're going to spend so many millions of dollars on this particular intervention, but more about what were what was the flow path of the thought processes that we went through. I do want to let everyone know ahead of time, my computer sometimes decides to randomly turn off my microphone and turn off my speaker, and we've worked out a process with Esther that she'll wave at me and I'll know to turn it back on. But if I suddenly go mute, it's a glitch in my laptop that we'll work our way through. So again, to start, I'm going to talk about our Stormwater Integrated Resource Plan, which is the strategy we're implementing for flood mitigation in Edmonton. So just a bit of background on the project. So in late 2017, the drainage utility in Edmonton was transferred from being a municipal department at the City of Edmonton into the EPCOR domain. And so EPCOR is a utility. We are 100% owned by the City of Edmonton, but we actually have operations all across North America. We're in Arizona, New Mexico, Texas, Alberta, BC, Saskatchewan, and Ontario. The strategy that we developed, it was specifically for the Edmonton operation, but we are also looking at how we can leverage the methodologies into other parts of the of our operations across Canada. So in terms of the mandate that we were given by our city council, who's still our regulator for our drainage utility, there were three main things they wanted us to look at for stormwater planning. One was, confirming what areas in Edmonton had the highest risk of impact of flooding. What would be the different drainage infrastructure programs to address those risks, and how could we ensure that as we're doing through that process, that the homeowners are aware of the actions that they can also be taking to reduce their risks. The city of Edmonton, prior to the transfer to EPCOR, had done extensive work on flood mitigation strategies. And so we were really able to leverage all of that work into our strategy. But what we did is we took that work and applied the lens of integrated resource planning, which is something we had been doing in Edmonton for many, many years. As part of our strategy in terms of our commitment to being a very public process and educating the homeowners, everything that we've done along the way is available publicly. And so at City of Edmonton, through utility committee meetings, we went and presented our thought processes as we developed the approach, got input from council and the public in different sectors at these different committee dates. And so for each of these dates, there's a comprehensive report. You can also go to the utility committee homepage and listen to the live stream of the presentations and the Q&A with councillors that we had at that time. We are actually scheduled to go back to utility committee on August 27th of this year in conjunction with the insurance industry. Hopefully having someone from IBC attending with me, and we will be giving an update on where the interplay of insurance and municipalities is sitting in terms of flood mitigation at that time. But again, everything is publicly available. So there's this slide deck is made up of sort of the highlights of each of those individual presentations. And if anybody wants more details on any aspect, there's a deeper dive presentation probably available for you. I've also, as mentioned, done a lot of public speaking on this and have done more customized research presentations with individual groups. And so that is available as well if anybody's interested in diving deeper on any of these items that I'm going to present. So first of all, I want to talk a little bit about what integrated resource planning is. Not a lot of utilities use these techniques, although some are starting to explore it. And certainly on the stormwater side, it is a lot newer. The integrated resource planning actually originally came out of the power sector in the late 1980s. In early 1990 period, we adapted it for the water sector in EPCOR, and I was the lead individual on that. And so that's one of the reasons I was asked to step out of my role as head of water distribution and transmission to lead the team developing the stormwater strategy. And that was a fairly big leap for me. I basically had a team of 340 people that was responsible for everything to do with the water distribution system. And I moved to a team of 4 where we were looking at, okay, how can we adapt this techniques of integrated resource planning into stormwater? But my background was water distribution, and really, on the surface was aware of the stormwater issues, but didn't have a deep technical background in there. So what integrated resource planning is an approach to master planning where you look at, what are the constraints that you would typically have when you're developing your master plan, and you want to challenge them and say, is that a true constraint, or is there another way to achieve the objective that we're trying to get to? It involves a lot of looking at operational interventions, not just capital interventions, which requires a bit more skin in the game to have the technique be more successful. And so, just to highlight how that had worked on the water side, within Edmonton, we have reduced our per capita water consumption from 270 liters per person per day down to 170 liters per person per day since we started using IRP. And that was all about changing customers' approaches to how they used water and interacted with the water distribution system. We also were able to increase the capacity of our treatment plants by looking at watershed programs to improve the quality of the river water, to improve our ability to produce treated water. And those two elements allowed us to really defer a major plan expansion from 1992 to 2006, which has a capital impact to the ratepayers. So looking at stormwater, the first thing we did was say, okay, what are the types of constraints that we have from an integrated resource planning perspective that we would want to explore going forward with stormwater? And so probably the first one for me was this whole, what storm are we designing for? The 1 in 100-year storm, or the 1 in 50-year storm, or the 1 in 200-year storm? That was always, there was a lot of conversation and a lot of material out there of people trying to figure out what the right number was. What integrated resource planning did for us is we said, okay, let's step back a bit. And what is the purpose of that design standard? And so if we're saying a 1 in 100-year design standard, what we're really saying is we want to design so there's a 1% chance of somebody experiencing damage in any one year. Stating the problem that way opens up the alternatives to avoid the damage. It's not just about moving a volume of water in a pipe to a specific location, but can you start to flood proof? Can you start to change the way the water is coming off the land and getting to that pipe, and using all these different techniques towards that? Another big finding for me as we went through this was this assumption that the same design standard for stormwater has to apply to every property equally as we go forward. That isn't consistent with how we approach fire protection and fire hydrants on the water side. We understand that commercial properties have a higher fire risk, and we provide higher levels of protection to those locations. So we broke that paradigm as well, looking at recognizing that there's certain properties that are at much higher risk than others and maybe require a different level of protection. And so I'll go through, as we go through these slides, some of the different choices we made as we went through those approaches. So the other piece of the work that we did, because as I mentioned, I was new to this, so I had to get up to speed very quickly in terms of what were the stormwater techniques that were out there that people were using. And so we did extensive literature reviews, talked to lots of other communities to see what were the programs they were using. Very early on, we determined that really at the city of Edmonton, although they had done a lot of great work, they were really only looking at 3 types of approaches to manage flood mitigation. And so the first was looking at building new trunks and doing sewer separation in their combined sewer network, adding more outfalls and some control gates at the river valley, and then installing a number of dry ponds throughout the system. They had, however, constrained themselves in that they said the only ponds they would consider needed to be a minimum of 2 hectares in size. The thought process being that that was less homeowners and property owners to coordinate with, and really landed that only dry ponds could be installed in schoolyards or major parks. And that wasn't consistent with what we saw in other cities where they were doing more pocket ponds, smaller locations, serving a few blocks. And so we opened up that we should also look at that. But some of the other things that were not in the strategy that we thought needed to be considered from an IRP perspective was the addition of looking at your maintenance programs. So if you do have an area that's at higher risk, perhaps you need a higher frequency of catch basin cleaning. Do you want to make sure that those assets are in much higher condition so that if there's standing water, you're not going to get high inflow infiltration into them because there's a higher risk at that location. From an emergency response and weather forecasting, certainly from an EPCOR perspective, we're a power utility as well as a water utility. We are very used to running a 24/7 control room and understanding when a storm is coming in that we need to change our operations and, in preparation, basically battening down the hatches. And so when we looked at the number of sensors that we had in our stormwater system, it was almost nothing. And really it limited our ability to do real-time management and understanding of, as the storm is crossing across the city, are there things we can do to hold back stormwater to avoid that impact to the community versus thinking that everything just runs in automatic and goes to the river as fast as it can. On the low impact development aspect, that was an interesting one. I ended up landing that it's really like the early days of the toilets in the water conservation world, where the first toilets didn't really work quite well. People were doing things like putting bricks in toilets that maybe didn't work as well as they should. A lot of that had happened in the early days of low impact development. The end result, there was a bit of skepticism out there for the people that were not as familiar with what it could do. And, really we're in 4th generation of low impact development. And there is proven literature out there that it is an effective tool to manage stormwater. And so we have a bit of history to overcome in terms of perception. The other piece really with low impact development is that most of the concerns that as we're moving forward, we've sorted out from a stormwater and summer perspective, it's very useful. Where I'm seeing the emerging concerns most showing up now is on the roadways perspective around the winter performance. And is there risk of increased icing? What's going to happen as a sidewalk going to become more slippery and someone's going to injure themselves? Is an ice lens going to expand and cause a failure? Those are the questions that are emerging now that I think from a Canadian perspective, we need to work our way through. But as with toilets, I'm fully confident we will get through that. And then finally, the floodproofing. Really, floodproofing of a property is the #1 thing you can do to protect it from damage. But because it was across the property line, traditional municipalities and utilities tend to say, well, my role stops at the property line. I need to start thinking about, from an integrated resource planning perspective, that I can cross that property line and start working directly with those customers and doing more there. Certainly on the water side, the example that aligns with that is where the utilities are going with lead water services and removal of those, seeing that there's a role for the utility across the property line to protect the risk to the customer. And so from an integrated resource planning perspective, we opened up our toolbox to include all of these potential mitigations and how best we could incorporate them into the utility. The other advantage I had as I was doing my project, in parallel to my work, the city of Edmonton, who's a member of the Covenant of Mayors Initiative, was also doing a major climate change adaptation project. And they were hosting a series of workshops where they looked at a number of different climate hazards against 17 industry categories in the municipality to see how these different climate hazards would impact how that industry would respond to a climate event. And that included flooding as well as wildfires, heat, ice storms, etc. And I was really fortunate that I got to sit in all of those workshops and meet multiple people throughout the community that were concerned about climate change and how it was going to impact them. So the city of Edmonton ended up publishing basically their report that shows that the hazards at a citywide scale in terms of what are the direct service impacts from climate change, but also what are the indirect service and impacts in there. And the example I use to describe the difference there is a direct service is the hospital's been flooded. An indirect service is the parking lot to the hospital's been flooded, but the hospital can still function. And then indirect is the road to the hospital's been flooded, and so nobody can get there even though it's able to function. And so thinking about those different dimensions of impact and what flooding can do to a business was very important for us. What we wanted to do with CERP, though, was take that down to a more local level at the property scale in terms of what would be our interventions going forward, knowing that flood risk, and in particular pluvial urban flooding, was one of the high risk areas for Edmonton going forward. River flooding or fluvial flooding is a risk for Edmonton, but it's a much smaller dimension because most of our river valley is quite deep and we don't have a lot of development in there. The other thing I did, and I'm sure I've met many of you in the media in the past, is I joined every single committee that I could find that was working on this, because I, again, had a very rapid need to get up to speed on what was going on. And so I'm sure all of you are aware of the initiatives that Insurance Bureau of Canada is heavily involved in. And Craig Stewart's been a great support, and Chris Roll to help me get up to speed on stuff that they've been doing, as well as at the Intact Center on Climate Adaptation. I joined a number of their working groups and really leveraging their best practices that was coming out of there and how that could feed into our program. As mentioned, I'm on the board of directors of the Canadian Water Network. So the Canadian Water Network, and in particular the Municipal Consortium Leadership Group, represents, I think there's the 20 largest cities in Canada are members of that. So that represents a population of just under 70% of Canada's population. Well, we get together at least twice a year, and now virtually it's actually more than that. But we talk about at the senior level, what are the different policy drivers and initiatives that are impacting us as utilities and municipalities. And so we were able to leverage that forum to make sure we had alignment across the country. We also invited the leaders of the insurance sector to come to one of our meetings, and we had a really good session talking about our different perspectives of risk management. And then finally, my broad network of industry contacts, I had a lot of one-on-one contacts with communities across North America and even into the UK with Anglian Water. Their Make Rain Happy campaign is a really good one for community engagement and how we could leverage some of the learnings that they had and bring it into a comprehensive strategy. One of the key pieces of research that was completed as a joint initiative with Canadian Water Network, Insurance Bureau of Canada, and Natural Resources Canada is we wanted to look at the accuracy of the maps that the insurance sector was producing. And so 5 cities from the Canadian Water Network participated in this initiative, and we provided LiDAR data of our communities to JBA and Aon, who were doing, catastrophic risk modeling to see what would be the impact if they were to get a higher resolution topographical grid from the federal government in terms of the accuracy of those insurance maps. And so really we tested a number of different things. Did we need to get the pipe data in there? What was the impact of doing a 1 meter, a 2 meter, a 5 meter, or a 10 meter grid resolution versus the current 30? Out of that, probably the key finding was that if the federal government were to provide a 5 meter topographical grid, that would have the most impact in terms of improving the accuracy of those insurance maps. From a utility municipality perspective, what was really useful for us out of that research is it showed that the insurance maps, although there are some inaccuracies with them, the inaccuracy is that it tends to overpredict wet, which means they're still very useful tools for us as an initial prioritization screening tool. If they were under predicting wet, that would be less useful for us because then we would have properties that were being missed in the analysis. But we are able to use the insurance sector maps as sort of one of our first phases of data input into an area that maybe we need to go and do additional engineering analysis in, which is very cost effective for us. And so the insurance maps are fully integrated into our strategies going forward as a key data set. There are still lots of uncertainties though. And so it is a multi-party discussion as we go forward. The stage we're at right now, we've got insurance and private sector funding, we've got municipal governments, and we've got the role of the private citizen. And we're all still finding our way through that. And so these conversations, so similar to me coming here and presenting here and having others doing that cross dialogue is really important as we go forward. I just got some recent numbers from Insurance Bureau of Canada showing that overland flood insurance in Alberta, for example, only 50% have opted for it. Now that's up from 30% 3 years ago, so it's moving in the right direction, but it still is a gap. And it's a concerning gap because the provincial government has now announced that they're going to limit the eligibility for disaster relief funding in the province of Alberta. And so we need to be aware of that as stewards for our citizens, that they're aware of that risk that's changed in their environment. There is the other piece that I'm really concerned about that we're working through is once as we move forward as municipalities and utilities and implementing our improvements, how is the insurance community going to know that the risk is lower? I think on a flood proofing of an individual property, there's good mechanisms for that. There's easy ways to assess the overall community. Do you have programs like our SERP? But when it gets into, we've installed a dry pond, what customers' risk is lowered, that's the communication channel that needs a lot of work. And I'm still trying multiple ways to crack that nut. And if anybody has any ideas, I'd be glad to talk about that. And so, yeah, just lots of discussion on there and continuing to be very actively engaged in that end. And part of the report I'm doing at Utility Committee this August is going to be touching on this dynamic in particular. So how do we do the project? So the first thing we needed to do was do a risk assessment, taking the citywide climate change risk and bringing that down to the more local level. And so we ended up choosing an approach that we took the city of Edmonton and basically divvied it up. It actually ended up being about 1,400 sub-basins, and the little map on the right shows what a sub-basin typically consisted of. And it tied to the pipe network from the modeling perspective, what was the catchment area. But then we also further subdivided it if there was a topographical feature above the pipe network that made the flooding a little bit different. And then for each of those sub-basins, we did an individual risk ranking and looked at it through 4 dimensions in a desegregated risk approach. And so you'll often hear people, well, they'll do a triple bottom line risk assessment where you mush the risks together. Our integrated resource planning technique actually has you look at those risks independently when you're doing your initial prioritization. And then you can start it makes it much easier when you're looking at alternatives to reduce the risk if you approach it that way. The 4 categories that we selected align with the City of Edmonton's climate adaptation strategy, because we anticipate in 10, 15 years time, perhaps flooding isn't going to be the highest risk in Edmonton. Maybe urban wildfire is. And so at some point, council is going to have to make decisions on investments as to what's the higher priority. So it's really important that our methodology is aligned with the other climate hazards that are being assessed in the community. A couple of points, if any of our records, so all of these maps, since we did our analysis, were available publicly out there, but we were very clear that the risk level that was assigned to the basin did not mean that every parcel was equally exposed to that risk. It's just that that risk existed in that basin. When we get into the more detailed mitigation analysis, then we start looking at, okay, this parcel is more impacted than that. What are our solutions to go forward? The other major change we did compared to traditional master planning, and this came out of the session that we held with the insurance leaders at Canadian Water Network, is that we stopped looking at it from a single design standard approach and really said, we need to start looking at risk over the spectrum of storms, so that we took the 1 in 20 up to the 1 in 200. Because we had acquired the insurance maps, we actually have up to the 1 in 1,500 that we're able to leverage into our data assumption, but also looked at what was that risk to that property over the lifetime of the property. And so we think of 1 in 100 years and 1% in any 1 year, 26% over 30 years, and 63% over 100 years. With some customers, our parcels, that 63% over 100 years may not be tenable. So we think of our water treatment plants in Edmonton. They've been in their River Valley locations since our one plant since 1895. It's had a number of floods over the years. And so the flood mitigation approaches we're looking at for our treatment plants, we're actually looking at a 1 in 500 years as more appropriate for that location. But by us analyzing it across this likelihood, you can start to look at the social dimensions of flooding and impacts and what is the right target for that particular parcel going forward. And the other piece I'll really highlight is this was a GIS exercise, not a modeling exercise. There were models that were GIS data sets, so the outputs of the models went in there, but we really approached it as a GIS exercise, and we acquired all the data sets that we could find that were out there for Edmonton. And so we had a mix of stuff that was within the utility, from the municipality. We were able to get information on the social dimension of locations of facilities. The provincial had done a lot of stuff after the Southern Alberta floods, so we were able to leverage that information, as well as the fluvial mapping, which is certainly a lot more accurate than the insurance maps. The provincial maps are more accurate for the fluvial perspective. We did purchase the insurance maps as well. They were put right in there, and work management data was thrown into the mix. And so, we had the modeling data, but then we also had asset conditions that show the assets in this area were a little bit worse than others. We assigned a higher consequence or likelihood to that particular basin, just because we had asset information that showed there may be another thing at play in this location. And so, yeah, just lots and lots of different data sets. And as we get new data sets, we're able to add them in. And so one of the data sets that we are in the process of adding in is underground parkades, and understanding that, the risk that comes into that. That's not a data set that typically exists in a community. And so as we're working through the community, we're adding that in and adding that risk into our risk ranking. The other big piece of work that we did was a very detailed public opinion survey. And so we worked with a professional surveying firm that had a really strong database of Edmonton participants, and made sure that when we went out, we were catching income levels, male, female, age, education levels, people that lived in high rises versus people that lived in houses, infill areas versus new developing greenfield areas. What else did we look at? Do you park in underground parkades? All of those different dimensions were tested and in part of the public opinion survey. And we did what's called a max diff survey. And so some of you may have participated in those, where you're given a choice of 5 things and said, if you have limited funding, what would you fund first versus what would you fund last? Each participant spent about 30 to 40 minutes in the survey going through multiple dimensions of flooding. And the risk statements that we created were not, should we protect to a 1 in 100-year flood or a 1 in 50-year flood? We translated those into the impacts that could be in a community. So for example, one of the scenarios would be, you have 6 inches of water in your basement. Your elderly parents have been displaced from their seniors home and now have to live with you for the next 3 months. Your commute time is doubled because the underpass is flooded. The trails have been completely wiped out because of erosion, or there's water in your street for the next 2 hours until the flood has passed by. And so all of those statement questions are available, and our full results of this survey are available on our website as well, if you want to look at them. Because of the way we structured the scenarios, they actually apply for the other climate hazards as well. So you could just replace wildfire for flood and have a lot of the similar impacts. So the results were really interesting, and what came out of it, loud and clear, statistically different, was that the citizens of Edmonton, the number one thing to protect was the hospitals and essential services. And some of the comments that we got was, well, if I'm dealing with a flooding event in my home, I want to make sure there's power and water to help me clean up, and that the hospitals and the social service agencies are there to support me in that mitigation. Risk to human life was also something very important to the community. And then after that came the financial damages. And so prior to us having that survey, the only conversation that was really happening was around the financial damages, who pays, who benefits, and should we be doing this, and where do we go? And so this really helped to bring up to the forefront that if we start thinking of it through this lens, the financial damages comes along with these impacts, but it helps to set the prioritization. For Edmonton in particular, where this was a really important thing for us, was related to our underpass flooding. We have a number of underpasses during major storms that see significant flooding, but it was always this debate, should I be investing money in that before something that's going to cause financial damage to someone's basement? Out of that discussion, we were able to determine that yes, the underpass is important because the depths are such that someone could drown in there. But the solution doesn't mean we stop the underpass from flooding, as we stop the risk of people drowning. That's what the IRP approach is. And so we are in the process of adding underpass flood warning systems on all of our underpasses. And I think we've got 3 installed so far, with a level sensor and traffic signage that will divert traffic away from the underpass if we see those underpasses starting to flood. So that's just one example. I will say the environment did not do well in the public survey. And us as a utility have obligations with our regulators to protect the environment. But from a public perspective, investment in dollars solely for the environment was not the highest priority. It truly was the risk to human life and social services. That was where they wanted to see the money going for investments first. So just as this slide here is a bit of an overview. So our October 2018 report to Utility Committee had this in more detail. But basically you can see our risk grid. Each of those dots represents one of the subbasins. The map is showing where the risk is occurring over multiple storms. We also have the maps available at each individual storm to see where that risk fits. But I wanted to highlight this one because why it was so important for us to do this as a GIS exercise. And so from a GIS perspective, we were able to take an example data set, for example, depth of flooding, and look at it from the perspective of a health and safety risk. Depth of flooding has risk of drowning. Is it a rapid risk or a slow risk? Depth in your basement is a slower risk than depth in an underpass. But it's also a financial damage risk. Now, how we interpreted that data from a health and safety, we said if any one parcel in that basin had that risk, that's what set the risk level. On the financial risk, it was the percentage of parcels that were impacted that set the risk level. Similarly, for combined sewer overflow or sanitary sewage discharge, the health and safety risk was exposure to sewage, and the environmental risk was exposure to our regulatory requirements in that area. And then the social risk was applied if any of the other three risks occurred, and there was one of the social categories existed in that basin. So what we did after we had desegregated everything and had a full understanding of it, we had to bring it together in order to build our full prioritization of interventions. And so we were able to use the public engagement work, which told us that health and safety and social were higher priorities in the community, followed by financial and environment, to weight those 4 risk areas and bring it together. So this was a fair bit of math, but it brought it all together. Now, this map is really interesting because what we're able to say out of it is, anything group A to E, EPCOR is going to be working and proactively doing flood mitigation efforts in there. In the other groups, we will assess if someone else is doing an initiative in that area, we will look to piggyback with them. And so it sets some priorities there. The changing of the risk ranking between the factors doesn't change the top 100 basins. They are always consistently in the top 100. There's a slight shifting of the order, but they're still the top ones being addressed. This figure tells us where we need to go first. It doesn't tell us what the mitigation is. And so if you can see my cursor here in the middle, we have our Rossdale water treatment plant, a major substation, a gas substation, and a bunch of customers in here. So the level of mitigation that goes in here is a lot of flood proofing, education, and all that. Versus in the Southwest, we have the Terwilliger Dog Park, where really the flood mitigation is emergency response protocols to keep people out of there when it's flooding. This area in the Southeast is really interesting. It's a high risk area because we have a creek that's environmentally sensitive. It's a combined sewer area, but we also have a lot of seniors facilities in that location. So we have a more vulnerable population that's going to be impacted by flooding. And so we want to look at our scenarios in that location based on that customer mix. And so, yeah, it's a very interesting way. So as we move forward to mitigation, we're able to go back to this and say, okay, what was driving the risk in here and what are the mitigation efforts we can do to bring that back? So after we had that map, we went through and looked at it at a basin level and said, okay, what are all the different interventions going back to those 8 techniques that I mentioned previously in our toolbox for mitigation? And out of that analysis, we ended up landing on this approach, which has our 5 themes of slow, move, secure, predict, respond. And if I were to characterize the previous strategies that were being developed, you would have had a very big move box and a very small slow box, and secure, predict, respond were not included at all. And so under slow is where we're talking about changing the way water flows off the ground once it hits the ground. So dry ponds and low impact development, and that is the bulk of our investment. We still have some move components to get the water appropriately to and from the ponds. On the secure side, we're looking at floodproofing of properties, outfalls, automatic control gates, and really inflow infiltration is a big focus for us and going forward throughout the city. Rather than just accepting it, let's reduce it and get rid of it. On the predict side, we're looking at a number of censoring out the network and having more automatic controls. So as we can see, as the storm is coming and going, we use our ponds more proactively to store water and release the water after, rather than just having it based on set levels. And then finally on the respond is having more appropriate or different emergency response equipment as opposed to just sandbags. One of the things we did as part of our public outreach is we went to all the major businesses in the river valley and asked them to see their emergency response plan. And all of them said they're going to call us and we have sandbags. It took us a while to find our sandbags. They were under a tarp in the back 40 of one of our yards. And so now we're looking at what are some other equipment we can use that isn't necessarily a sandbag to deploy for barriers in an emergency response situation. So a couple of drivers that really drove our strategy. And so there's two of them I'll talk about. So the first one that we discovered as we pulled all these data sets together is that really the most damage impact increase was really due to surface ponding occurring in topographical sags. And I know all of you have seen the figure on the right, which is, from the CSA standard. But the figure on the left is a mashup of basically the insurance maps and then our historical maintenance records of basement flooding that have occurred in Edmonton over 20 years. The green is the 1 in 1,500 storm from the insurance maps. The pink is the 1 in 100. If I layered on the 1 in 20-year storm, it would be just slightly smaller than the 1 in 100-year storm for these major topographical sag areas. So this area up here is actually an old lake. It's McKernan Lake. It was paved over in the 1940s and made into a subdivision, but it still wants to be a lake. And so that's where we see increased flooding. This location here doesn't have flooding in the middle because that's a schoolyard. And so that's that one, we're building a pond right now. We just finished commissioning it. And so that's the naturals. Very rarely do you get the pond location aligning where you have the land available. And then finally, further down south here is one of our other ponds that we've built. And this is where one of the challenges with the insurance maps is they're picking up that existing pond and showing it as a high risk, as opposed to it being the location where the water's supposed to go. And so these are the things we need to sort out. This little area here was really interesting because it's just a couple of blocks that are a slight sag but have really high risk. And if you're doing planning at a neighborhood scale, you wouldn't necessarily pick up because it's just a few properties or only looking at one storm. But looking at 20 years of flooding, you can see there's a higher risk there. And then finally, this little area here is a little bit offset from this area, but that's the boundary of our combined and sanitary systems. And so understanding what's going underneath it at the piping level helps us to figure out, okay, what do we need to be doing in this location? And so by us having all these data sets, we're able to look and figure out different things that are driving flood risk in our community. The second theme and ties to the low impact development challenge, and everybody's saying, well, it can handle the major storms. It's not going to work. And so we looked very closely at the different types of low impact development and some of the test data that was out there, and showed that for the four of the types in particular, you can get a very high capture at a low storm level, and then even a 50% at a 1 in 25 year or 40% at a 1 in 100-year level. So then we went and looked at some of our radar plots of some of the major storms that had come across Edmonton. And so this is one of the recent 1 in 200-year storms in 2016 and 2017, where we had significant flooding. I live right here. I had damage in my property. But it was also a case where we had significant underpass flooding right in this location here. And so everybody's like, well, of course the underpass flooded. It was a 1 in 200-year storm. But when we actually looked at the radar plot, it was actually a 1 in 10 to 1 in 5-year storm that had occurred over that region. It was just that our storm pipe network was capturing all that water and rapidly delivering it to the freeway. And so this is where we can start to look at if we could actually hold that water back in the ponds for a bit or sequence the release of them, we can eliminate that ponding occurring in that underpass. Just recently, one of the other things we've done is we have a location right here where we occasionally get a fairly spectacular geyser that forms. It's about a 20-foot geyser that comes out of our stormwater. We've now, through the initial work of CERT Predict, confirmed that if it rains in this basin before it rains in this basin, we get the geyser. If it rains in this basin before it rains in this basin, we don't. And so now we're looking at implementing a strategy here to better control how those two peak flows come together to avoid the geyser from forming. So really interesting stuff as we bring these data sets together and analyze it much more detailed. So in terms of how that's meant from a cost perspective, and so what this chart is just showing is on the left is what the previous City of Edmonton strategies were. Again, those traditional, using only those 3 tools out of the toolkit. And they were looking at about an 80-year time frame to implement it because it was a lot of pipe construction. By us looking at it through these other dimensions and truly targeting the risk that the customers are facing, we're very confident that we can do this for considerably less costs, but also within 20 years. And for the secure, predict, and respond, we're going to be getting the most of that done within 10 years. And it's the lower cost components of the strategy. The longer strategies are the low impact development in the ponds. And that's really more about, you know, the negotiation and the impact to the community as you're putting all these components into your infrastructure. But, you know, the one thing is it's not just a capital solution. We are changing the role of the municipality and the utility in flood prevention. And so we do need some additional staff to manage these programs. So if we're going to real-time controls, we need people that can manage and control those systems and make sure they're functional. As we're going to more green infrastructure, it's a different type of maintenance than pipe maintenance. Ditches and swales and culverts was another thing we discovered through our analysis. Nobody was looking after those. And so as part of COVID, we accelerated our ditches and swales work because we couldn't get into people's homes. And so we've done a lot of work assessing almost 4,000 culverts throughout the city. We've got over half of them inspected, and a number of them required repairs and then cleanup of the hydraulic paths on those. And we now have an annual maintenance program that we're implementing to keep those functional. Our backwater valve subsidy program, we've had that in place since 1998. We've offered free flood inspections to homeowners since about 2004. We've doubled the staff for flood inspections, so we have now 6 full-time flood inspectors. And we are going to go out and target those customers in the high-risk areas. Our focus, once COVID lightens up and we're able to get into people's homes, will be the River Valley neighborhoods first, but also things like that old lake bed, making sure all of those customers who do have backwater valves are properly maintaining them and keeping them going forward. There's a number of financial considerations we had to go through as well. So, you know, what timing would it be appropriate? Alternative rate structures, pervious versus impervious. Currently, Edmonton's rate structure is based on land zoning and set rates. We'll probably be looking in 2024, 2025 for some alternative rate structures that focus more on pervious, impervious. Just didn't have time to get that in place. Talking about who pays for stormwater, is it all properties in the city, even though, or whether or not you're adjacent to a stormwater pipe, sorting through that. If we're going to be investing in low impact development on private property, how do we have the permitting in place so the property owner doesn't rip it out later? Making sure it's functional. Capitalization of green infrastructure was a big piece as well. I like to say that it has to have a component that an accountant can put in a truck. And if they can put it in a truck, then it can be considered a capital asset. If it's just a depression, it's probably not a capital asset. And then us looking at how we can invest on private property. There are examples tied to the lead water service renewal that we're leveraging into the green infrastructure on how a utility investment on private property can be considered part of rate base. And so that's really important for us. So that's a real whip through. I do have some additional slides that go into more details on what we are doing in each capital, but I find that looks better to maybe leave that till later as part of the questions. And if somebody has a specific question, we can pop to that slide. And so I will open it up for questions now, and I came in pretty close to on time.
Thank you so much, Susan. That was so informative, particularly liked the part about the surveys that were done in your assessment. So first of all, it was really informative. In the words of one of the attendees, quite spectacular. So thank you for all the information on what Edmonton is doing and what EPCOR is doing. I will start off with a couple of questions. We'll wait for the attendees to add more to an answer chat box, but I know it can be very challenging to sometimes get the buy-in of homeowners when you're looking at taking certain mitigation steps towards mitigation, not just for flooding, but for other hazards as well. I'm just wondering whether there were any challenges around getting the buy-in of homeowners in this plan, because I know it was a multi-sectoral, multi-stakeholder approach.
Yeah, so I'll answer that question from a couple of perspectives. So certainly, our public engagement was more about setting the investment stage and where the priorities would be, less about saying you should be doing this to flood-proof your property. But certainly we have had our backwater valve program and our flood prevention program in place, flood-proof inspection program in quite some time. And so that is actually something we're looking at right now is we've probably caught all the early adopters over time. So the people that are aware, now we have to go a bit deeper. And so we are actually going to be working with some professional firms on almost a customer capture strategy. So similar, if you were a business looking to get more people to come to your drive-through, we'll be looking at targeting that. For myself, the approach I've been taking is breaking it into sort of three groups to move forward. And I'll talk about it more probably from the green infrastructure perspective. And so what we've strategically done is we've started by looking at working with the city's roadways department on how we can get green infrastructure implemented into the road construction process and addressing their issues and get it to the point. My big, hairy, audacious goal is green infrastructure should be as easy to pick out as a catch basin. And so we can get to that point, then it just becomes, again, part of their toolkit. And so we started with them last year and worked through, and we started with bump outs and tree cells. Just very simple, start, get that going, get comfortable with it, and then we'll move into bioretention and I think box planters. Our next strategy group is really the commercial sector. So going out to entities that have large parking lots and what are the issues that we can do with them. And some of the stuff we're finding as challenges there is we're looking at a 30-year view. They may be looking at a 5-year view of operation of their business. How do we put something onto their property that's not going to restrict them from their future plans, but then protect our investment? And so those are the sort of the challenge conversations we've had. At the residential level, what we're doing strategically is reaching out through the community leagues. And so there's 270 community leagues in Edmonton. They have what's called a Green Leagues program. They have a long history of doing stuff on energy efficiency. We're expanding that now for flood mitigation and going into there and then offering with the community league, say, hey, on Saturday, we're going to be in your neighborhood. Do you want to sign up for a flood-proof inspection? Or how could you do green infrastructure in your property? We will still offer the individual work, but we really do want to get to more of that work with the community leagues to do that piece. And we've also joined BOMA as an example to hit the commercial properties and share the knowledge with them as well.
Thank you for that, Susan. We do have a couple more questions. Do you have any concerns with LID features being located near private side lateral? So when on private property? The attendee is mentioning that this is a concern in Ontario where properties are sometimes only 35 frontage.
Yeah, so in that location, we would probably look more at a box planter as a solution for the LID. So we wanted to make sure in our design standards, we had a mix of tools that were really standardized that we could go forward. The other tool that was in there that I didn't mention is we also looked at green roofs as an option, but that was so much on the private property and required other stuff. We didn't include that, but a green roof coupled with a cistern type of approach or a small pocket storage is also as effective. And so it doesn't always have to be the traditional LID of the soils and vegetation. We're actually counting small scale storage. It's about peak attenuation. And so for those type of properties, we might just install a small scale storage there and just cut the peak off is really what our objective is.
Okay. And then related to LID as well, did you calculate the long-term maintenance costs of LID features?
So one of the things that we looked at is really thinking about what are the lowest cost maintenance LID features, and really that's where our initial focus is on standardizing them into, so our initial LIT guideline in Edmonton had 12 different types of LID. We narrowed that down into, okay, these are the 4 we're going to concentrate on, and then really getting those standardized. One of our aspects in our strategy is we do actually want to build a training facility to test a number of these where we can go with our maintenance crews and do stuff. Now, ironically, because we discovered that our ditches and swales also weren't being maintained that well, it's actually the same team. It's the same sort of approach. And so that's where those operational considerations come in, is that we've added the additional operational funding and the staffing to manage that. But we do want to make sure we're picking the more standardization we can do. It's going to be much easier for everybody.
Oh, thank you. We do have some more technical questions. So with regard to the GIS used, GIS it really sounds awesome. One of the attendees is saying that models end up being very inaccurate with the, when you use models, there's some inaccurate, I guess, readings. Mostly most municipalities maintain them. And not often. So the attendee is just making that comment about GIS that you guys have used.
Yeah, no, and one of my previous committee roles, I was on the board of directors of the Geospatial Information Technology Association and had done a lot of work with GIS in my past. What we did as we did our risk ranking is we looked at a particular area. We may have had 6 different models that were available. We had the insurance model, we would have had a provincial data, we would have had some of our own internal models. We basically just layered them all onto the GIS. And for the purposes of our prioritization, we took the worst one as the one that was driving in there. We can clean that up when it comes time to design the mitigation measures. Our purpose was to prioritize the city for intervention. And a really good example of that is around the ponds and the insurance maps saying the ponds are the high risk area, when in fact, that's where the water is supposed to go. What we've done in our risk ranking is we've applied basically the higher insurance risk in our risk ranking, and we are systematically going through and confirming our overflows are all working properly before we will dither that risk down, saying, we're on top of this. I wish I could figure out how to get the insurance industry to know that that's an actual pond, and that's my gap that I need to fix.
Yeah, definitely. We also have a question here. Is there a reason why the household program has focused on backwater valve installation rather than managing private side sources?
That's just a history thing. The private side sources is actually also part of secure in our inflow infiltration strategy. We have 100 million dedicated towards that over the next 20 years, and that will definitely be part of it. We are anticipating in we do basically 3 or 5 year rate filings. Our current rate filing is just in the process of being approved. We anticipate we'll have additional subsidies for that piece in our subsequent rate filing, which would be for 2024. Our focus right now is we're doing sensoring gas and smoke testing, trying to find out the source to get the scope level that we require.
Okay, that's understandable. One of our attendees also wants to know what your thoughts are to deal with additional runoff associated with densification,
yeah. And so that's tied to our infill strategy. So the city of Edmonton has a formal infill strategy where they're looking to get a certain percentage of growth through infill. Our team is working very closely with them, and similarly, that's why we're trying to standardize the type of LID we can use in there. I think where the difference, and this is where our discussions will come, is a lot of municipalities are not thinking about this as something that the utility or municipality is doing the investment. They're expecting that the property owner do the investment. Because we're getting a benefit to the broader system for this, there is a case to be made that this is something the utility should be investing in on the property, and it will depend. And so certainly, we have to make sure that it doesn't get ripped out after we install it, but thinking about who invests in that green infrastructure is different than mandating it that it be required.
Thank you. By way of inspiration, I guess, what other cities' green infrastructure programs do you admire? Who is doing it right? I know there's Vancouver, also Mississauga is investing in green infrastructure. Any others that you find?
So probably the ones that certainly Philadelphia, New York, their green hectares, or their green acres, and we call it green hectares, but we stole that completely from them, and using their components there. Rotterdam has, amazing different form factors of dry ponds. I think historically the dry pond has always been the sink the soccer field. We have one dry pond currently in planning phase. It's a dog park. And so I'm thinking, well, maybe we can do something where we have some benches for the people that can sit on as the wall of the pond, rather than doing the traditional slope in there. And so we'll want to look at innovative designs based on what the community is interested in. And so those are sort of the things I'm willing to steal a good idea from anybody in there. And so really across, Make Rain Happy from Anglian Water is a really good engagement campaign with kids. They have some fantastic videos of school kids doing stuff. One of the early communications we have done is with the Edmonton Public School Board. And so we've given them the flood risk information for their schools, and they're looking to see how they can incorporate that into their school curriculum as well. And in addition to that information, we give them the water consumption per student. And so they can look at doing different educational programs to reduce water consumption in their school properties as well, which puts more money into education.
Mm-hmm. And also related to green infrastructure, how do greenfield developers fit into the whole strategy?
At this point, our initial focus has been on the existing adaptation to work through all the concerns with the standards. Once something gets into our standard formally, then it is available for a greenfield development. And so that's basically been our approach. Now we do have one area in particular that's a greenfield that we've done a very detailed assessment from the infiltration reduction. And looking at that, we've been able to eliminate a $70 million sanitary trunk line by as looking at if we were to do an infiltration reduction in that area. And so it certainly is something that the development industry is very interested in, and we're working our way through it.
Okay, good. Looking now at, looking back at the plan again, does the Water Integrated Resource Plan differentiate floodplain flooding from table flooding?
Yes, it does.
If it does, and if so, do the results to date show a difference in between the two?
I'm not sure what you would mean by difference, but certainly their risk profiles. So the fluvial flooding and the pluvial flooding definitely are both incorporated into the strategy. And so that's why our initial outreach is into the fluvial areas to manage with those and looking at more accurate data coming in. So it doesn't really differentiate. It's all encompassing one strategy. What is really interesting is right now we're about a year into, or not a year, about 6 months into developing our sanitary IRP. And so we've got the water IRP, we've got the stormwater IRP. The sanitary IRP is actually being impacted by the water conservation in the water IRP and the change in inflow infiltration that's coming out of the SERP IRP. And so that's completely changing the approach we take on the sanitary IRP, where we've got the issues of solids deposition and H2S generation, and how are we going to manage all of these two things basically hitting the sanitary IRP quite hard in terms of an asset management perspective.
Okay. Also, what are your findings? What are you finding regarding resident maintenance of protective plumbing equipment?
It could be better, and it is something that we will definitely be focused on, especially for those ones in those highest risk areas. And that's part of us working with a professional firm to help us figure out that capture thing, and how are we going to best communicate with those homeowners. So it's not just about let's do the flood inspection and leave, but let's starting to think about annual maintenance programs. We have something similar on the water side for shallow water services that tend to freeze in the winter, where we communicate with them every couple of years or twice a year in terms of turning bleeders on and off and managing that. So certainly we have those techniques in the utility.
Also, have you seen interconnection between lost water and II in storm? II in storm uses up capacity.
So in terms of water losses, Edmonton actually has very low water losses. It's less than 4% of our total production. Some of that is the clay soils that we're in. Typically, if there's a leak, it does go up. So that's not a big factor for us. More where the correlation is on the inflow infiltration is in that topographical sag area and the risk of funding. So we've identified 9,000 manholes, for example, that we're going to be doing bowls underneath and inserting plugs, as well as sealing the walls of them to stop inflow from getting into them. So there's 9,000 out of our 80 some odd thousand manholes that are in sag locations that we're focused on. We're doing 1,000 manholes a year.
Yeah. And attendees are just thanking you again, Susan, for all the information, so informative. And we just have a couple more questions.
Sure.
If you mind. Are there incentives or requirements for developers in all of this strategy?
Not at this point. Really we have our subsidy, and then there's some stuff where we would potentially do the install, because we wanted to, the challenge with a subsidy is it's an operating budget and regulatory accounting. It actually is preferable for us to make it as a capital investment, where we invest and then it can be depreciated over the life of the asset. And that's much more beneficial for the ratepayers. And so us really looking at what are things that are considered capital assets are important for us.
Okay, we do have a final question here. How are you linking your initiatives to secondary benefits that might be associated with infrastructure? Example, urban heat island, walkability, public health aspects.
Yeah, and so where that fits in is it's more the City of Edmonton's climate change adaptation strategy. And so if you were to go look at that, you would see within their, I think they have 4 themes or 6 themes, I'm going by memory here. A number of their initiatives are directly ported from our SERP strategy and then tied into their stuff. So we work very closely with the city on all of these initiatives. And so we are part of that broader strategy.
And just one more thing, Susan, the public opinion survey that you all did, is that something that you do regularly and, see some changes over time, or was that just that one?
We do regularly engage with the public. This particular survey was specific for this project. But just when we go back to council in August this year, we will have another public survey where we asked individuals that had completed a floodproofing inspection, but had not followed up to get the backwater valve installed. And why had they not done that? And so we will be presenting those findings. And, ultimately it came down to 20% of them forgot to apply for the subsidy. They actually did the work, but didn't come get their $800. There were others that didn't really think the risk was really there. They didn't quite believe what we said. And then there was another bunch that didn't know how to hire a contractor to help them. And so that's, I think, another role for, as a municipality and utility, you tend not to want to pick winners and losers in the contracting community. But as a homeowner, if you've never hired a contractor, how do you know to start? And so how do you fill that gap is something we'll be exploring further.
Well, thank you so much, Susan. This has been very informative, I'm sure, for all of us. Just want to remind the attendees that our next Friday forum will be on August 20th, and we will have 2 presenters, one on the National Guide for Wildland Urban Interface Fires. That would be Dr. Noureddin Berichou. And we'll have Keith Porter as well, also providing a benefit cost assessment of that national guide. So please mark your calendars, guys. And we look forward to seeing you guys again. And thank you, Susan, again, and all the best.
Okay. Thank you, everyone.